This is a LEGO set of the Lunar Roving Vehicle, or LRV, the version of this that flew to the moon on Apollo 17 back in 1972. That was also the last time humans were on the moon. We're now in 2026, and NASA is hoping to get humans back on the lunar surface in 2028 through the Artemis program. And Artemis is now highlighted by a moon base.
We are leveraging the NASA playbook from the 1960s, figuring out what works and what doesn't in this epic science of survival.
That, of course, also means mobility. And that brings us back to the LRV, or at least a modern version of it. You may recall back in April 2024, we had this headline, which was when NASA announced a new competition to build the next generation moon buggy. A year after that, Spaceflight Now traveled to Colorado for the 40th Space Symposium. That's where we spoke with all three of the companies competing for the Lunar Terrain Vehicle contract at the time. You can check out that full report by clicking the link in the upper right-hand corner of this video. Fast forward yet another year and a change of administration, and instead of awarding one of these LTVs, NASA went with these.
I'm gonna get ready to announce the first LTV award winner, and that is Astrolab. The second LTV provider, which I'm gonna announce now, is Lunar Outpost.
With the new moon-based vision, NASA wanted to get lunar terrain vehicles on the surface of the moon faster, which meant asking these companies to create stripped-back versions of what they originally proposed. And in order to better understand why Astrolab went from the Flex rover to the Crew Lunar Vehicle, and why Lunar Outpost went from the Eagle to the Pegasus, we called up the founders of both companies and spoke with them about this new road to lunar mobility.
The competition drives all of the vendors to, perform their best, really, show NASA what they can do, meet those, very tight timelines that NASA has. And so I think the competition in this case is a good thing. It's going to lead to, the highest value, highest performance for NASA, for taxpayers, and, ultimately a very good thing for the cislunar economy and our moon-based vision.
With the original LTV contract, NASA required the competing companies to procure their own launch to and landing on the moon. As it happened, both Astrolab and Lunar Outpost chose SpaceX's Starship in order to maximize the mass that they could incorporate into their designs. But with the revamped moon-based strategy, NASA decided to award Blue Origin the landing contract for these lighter LTVs at a contracted cost of $234 million per LTV delivery.
Blue Origin's lunar lander product line has two variants. Mark 1, which is the uncrewed version, is what we're going to be using for the delivery of the LTVs, and Mark 2, which is the crew lander mission. So using Mark 1s will also reduce the risk for future crewed missions there. Mark 1 is the same type of vehicle as Endurance, which is featured in Moonbase 1, the first mission to the lunar surface. Mark 1 type of spacecraft is also going to deliver the Viper rover later in the fall of 2027. So congratulations, Blue Origin, and we are looking forward to this partnership to deliver the first lunar terrain vehicle as part of Moonbase program.
Addressing the elephant in the room, obviously Blue Origin's unintended explosion of its New Glenn rocket just 2 days after the Moonbase event did put a wrinkle in the planning for the rollout of the Moonbase to some extent. CEO Dave Limp did note in recent public appearances that the company does intend to launch New Glenn again before the end of the year, but he did note in those appearances that the launch of Blue Moon Mark 1 for the first time, that's now slipping from summer of 26 to sometime in early 2027. Now, in a recent trip up to Astrobotics facilities in Pittsburgh, Pennsylvania, I had the opportunity to speak with the Moonbase executive, Carlos Garcia Galan, about the impact of the explosion on the rollout of the Moonbase.
That plays into the whole strategy that we have to have different means of getting things to the surface of the moon. The more we can decouple those things, in better position that we're going to be in. For example, we want to have rockets that take our landers towards the moon. We want to have landers that can deploy different payloads, and we want to have those payloads that can go on any lander. So when we achieve that capability, if the lander is not ready, but the payloads are, we'll put those payloads on a different lander. If the payload is not ready, there'll be more payloads that we can put on the mission at hand. We don't want to be in the mode in which something happens, technical or something else, and we're waiting for 3 years to fly our mission, which was some parts of it were ready. So we want to achieve that this anomaly was kind of a wake-up call to the fact why it's so important that we achieve this vision of operations. And on New Glenn specifically, the anomaly, the team is definitely focused on, number one, understanding what happened, rebuilding the infrastructure, and get back to nominal operations. We will be in the process of doing that. In parallel, we'll be looking at different options for Moonbase and Artemis on how we can continue our mission without significant delays.
So how did awarding the LTV deliveries to Blue Origin impact the LTV providers? Astrolab founder Jared Matthews says that shift helped drive some of the changes to the vehicle design.
The biggest or most impactful change that was rolled out at Ignition was NASA's decision to go from a model in which we were responsible for the launch and landing, meaning going out and contracting with commercial providers, to a model in which they are responsible for it. And the difference is that when we were responsible, NASA didn't really have an opinion on how big or massive we were, because that was ultimately our problem to go solve in terms of landing on the moon. Now that they are, that they separately procured the launch and landing, which Blue Origin was selected for, that meant that we had to fit within a defined mass and volume allocation, which is considerably smaller than the one we were previously working with. So in this case, our rover CLV-1 has to do some robotic origami to fit into that volume, not unlike the Apollo lunar rover had to do in the 70s.
Further deployment tests were conducted using a full-weight LRV called a qualification test unit. The vehicle was deployed from a lunar module mock-up at the Grumman Aircraft Company, contractor for the lunar modules.
A key difference, though, is that, Apollo, they had the help of astronauts to unfold it and get it deployed. In this case, this rover will arrive on the moon, perhaps months before the crew, so it needs to robotically unfold and get mobilized and then traverse over to rendezvous with the crew arriving on Artemis 4.
Astrolab's animation of the CLV-1 being deployed on the lunar surface was shared during a press event on May 26th. Matthews said the Astrolab team was excited to learn that NASA wanted a more iterative approach to the LTV program. They were already buying down risk with their smaller, robotic Flex Lunar Innovative Platform, or FLIP rover. The first FLIP rover is set to launch on Astrobotic's Griffin 1 mission, which was rebranded on May 26th to become the Moonbase Mission 2.
FLIP was always going to be a test bed for LTV, so that's why FLIP has extremely large tires, because they were meant to be the LTV tires, and big overpowered wheel actuators and large batteries. And so, we've already obviously made a lot of progress there, and that is directly transferable to CLV. So it's hard to say as a percentage wise, how much work is ahead of us. There's still a lot of work ahead of us for sure, but we have a great foundation off which to build.
In a similar vein, Lunar Outpost has also been buying down risk for its Eagle LTV through smaller robotic rovers like its Mobile Autonomous Prospecting Platform, or MAP rovers. One of those flew to the moon on Intuitive Machines' IM-2 mission, but the Nova C lander touched down in such a way that the rover couldn't be deployed. Another MAP rover is bound for the lunar surface on Intuitive Machines' IM-3 mission, now called Moonbase 3 by NASA, which is expected to launch before the end of 2026. Lunar Outpost co-founder AJ Gemmer says another MAP rover is set to fly as part of a crewed Artemis mission.
Part of the Artemis Deployed Instruments program. So much like in Apollo, where the astronauts deployed various instrument packages and suites during their mission, again, the Artemis astronauts will be doing that. What's really cool about our mission is it'll be the first time that we have human-robot interaction, that our astronaut crews will actually have a rover companion there on the lunar surface to help them out and help keep them safe. So it's absolutely still a part of the Artemis architecture. I think with the new Artemis vision, we're still waiting for some information on NASA on where they'd like to fit that in. But on our end, we're proceeding at full pace.
Prior to the May 26th announcement from NASA, Lunar Outpost shared some photos and video of its trimmed-down LTV design that it calls Pegasus.
We've already built 2 versions of our static human-in-the-loop mock-up and completed 2 rounds of crew testing where we had an astronaut in a representative spacesuit go over all of the human factors of the Pegasus vehicle. We're going to continue that and extend it into full-scale drivable prototypes that will eventually be used as astronaut trainers. They'll be driving these vehicles in a representative lunar environment here on Earth, along with our digital twins and simulations that accurately represent the vehicle dynamics in the lunar environment and under lunar gravity. In parallel to all of this, we'll be building and qualifying the flight hardware. So going through our standard lunar mobility qualification processes, all arriving at a successful delivery to NASA in November of 2027.
The designs from both Lunar Outpost and Astrolab will be capable of autonomous operation on the lunar surface and will go through checkouts prior to the arrival of astronauts. They will also be parked a fair distance from future landing sites by either of the human landing system vehicles.
Protecting for PSI, we plan to keep the LTVs approximately 2 kilometers away when the landers land. And they'll traverse in, be able to pick up the crew, and then do missions up to like 10 kilometers during the crewed period, and then uncrewed, like Carlos said, total of like 400 kilometers throughout the lifetime.
During the news event, NASA didn't announce the exact timing of the rovers launching to the moon or which one is planned to land first, but both companies are contracted to be ready by the end of 2027.
We actually have to deliver the rover ready for launch by the end of next year, in 2027. The earliest that will likely launch is March of 2028. The timing relative to the crew arrival, I think, is not yet finalized, but yes, the idea is that it may have to traverse several hundred kilometers to rendezvous with the ultimate Artemis 4 landing site. It will likely get there ahead of time and do some scouting, and make sure that the area is well mapped and that there are no dangerous obstacles that NASA should be aware of before committing crew to that site. So that's what we're going to try to support.
Both landers will be used primarily for that early scouting purpose and will provide some key technologies required for long-duration use of the moon. Chief among them is surviving the harsh conditions of lunar night.
In sunlight, the surface can heat to over 250 degrees. In darkness, it can drop well below minus 200. In the permanently shaded craters, areas of great interest that have been untouched by sunlight for millions, even billions of years, temperatures can fall well below minus 400 degrees. There is no atmosphere to moderate these extremes, no protection from radiation and solar particle events, and the surface is exposed to meteorite impacts, including the kind of light flashes the Artemis II crew observed from orbit.
I'd say surviving the lunar night is the most difficult part of this endeavor, or really any system operating on the moon. And that is one of the reasons we chose to try to tackle that with our FLIP mission this year. So FLIP is designed to survive around a 100-hour lunar night. This LTV is required to survive around a 150-hour lunar night. In both cases, our approach is to essentially have a lot of onboard energy storage, so a lot of battery capacity, and use that capacity to keep things just warm enough while hibernating through the night. And the second tactic we use is to turn down our radiator. So, we have a radiator that rejects heat from the avionics in the daytime. But if you just let the radiator continue to radiate throughout the night, you're going to lose a lot of heat. So our approach is to actually cover up the radiator with our solar arrays. We're doing this both on FLIP and on CLV to limit the amount of radiation we have throughout the night. But to your question, yes, surviving the night is ultimately made easier with the more energy capacity you have in batteries, which is, essentially a mass problem. And so having to fit into a smaller mass box, provides an extra layer of challenge.
While these lighter landers will be arriving at the moon first, both companies say they are still very much pursuing their larger LTV designs, which could be ordered by NASA further down the road.
Eagle has a number of key capabilities, that we feel are really necessary for the full implementation of NASA's moon-based vision. So things like a robotic arm, a robotic manipulator, doing things like making interconnections between power and communications services, different nodes. Administrator Isaacman described this grand moon-based vision with lots of different installations. So all of those installations will need to be built, set up, connected to one another, things like that. And Eagle is really an excellent platform to do that. Similarly, hauling heavy cargoes, large, bulky, massive payloads from site to site, dropping them off, setting them up, that sort of a thing. And just like a work truck here on Earth, Eagle has a substantial towing capability as well. So when we're ready to start deploying, trailer type services, Eagle is ideally suited for that. Pegasus, in contrast, will get there first, still provide that high level of safe, reliable crew mobility, and I think really be used in an exploration and scouting role. So really checking out those sites that the administrator and his team described, potential candidate sites for the moon base. Pegasus is ideal for that, covering some of those steep inclines, things of that nature.
It's our aim to have as many rovers as we can get on the moon. CLV is really very crew focused, and so to the extent that we can continue to support Artemis missions going forward, I think there'll be a demand for CLVs. We're excited about the Flex platform really to enable other parts of the moon-based vision, particularly around deploying infrastructure and doing site preparation, excavation, compaction of soil, supporting mining operations for, commercial helium-3 companies, things like that. So, ultimately, I think there's a much larger market for that style of rover going forward. And but we're excited to serve both for as long as there's demand. Yeah.
And that demand signal begins with Artemis 4. Reporting for Spaceflight Now, I'm Will Robinson Smith.